What percent of students listen to Spotify daily? And what's the average salary for college grads? We cannot ask everyone, but we can use data from a sample to make an educated guess. A single number obtained from a sample data for this guess equal a point estimate. But we can go further. We can construct a confidence interval from this sample data, which is a range that's more likely to capture the true value. That's the heart of this chapter. Estimation for both point and confidence intervals.
So now let us look at the chapter in more detail. So again, we have two approaches to estimate an unknown population parameter. So basically, from the data we collected for sample data, we had two main approaches. The first approach is the point estimate. So here is the single statistic, which can be obtained from a sample. And then we use that to estimate the unknown parameter. So say, if you want to estimate the true proportion of people in favor a new policy, then you can take a sample and you can use the proportion of people in favor of the new policy to estimate for the true proportion of people in favor the policy for the whole population. And the second approach is the confidence interval, and from now on you see the abbreviation CI here to estimate. So here, we use an interval obtained from a sample to estimate the unknown truth. So now, the true proportion of people in favor of new policy is estimated by an interval. It's no longer a point. And here, a good analogy for that, right? So you think you try to catch a fish, right, which is the unknown truth. So one person, they use a fish pole. So it's kind of this a point estimate. And another person, they are a bit more effective. They use a net. So basically, you should imagine you should be able to relay that they have a more likely they're more likely to catch the fish, right? Because the estimation now is wider. It's not a point anymore. So the first approach basically is simple, which is the sample version. So if we want to estimate the true proportion of population, then just use a sample proportion. In this case, just p hat equal to x by n. N is sample size and x is the number of success, right? Which is number of observation with the desired property. And if we focus on the mean, mu, and then to estimate the underlying truth of the true mean of a population, we can use a sample mean x bar, which is a summation of x1 to xn divided by n here. So for Master 100, we just focus on two population parameter. One is proportion and another one is the mean. For sure, we have more than that, but it's not the scope for this class. So in this example A11 here, to estimate the mean mu height of US adults here, and basically you can conduct a poll from 100 people, right? And then from that, for example, the sample mean has the x bar is equal to 66 inches. So from that, you can use that as a point estimate for the true mean mu, okay? So say if you measure 100 people height, right, and you just add them up and divide by 100, and you got 66 here. So it will be a sample mean. Another example, we look at the shopping online trend of people, right, about Christmas shopping online. So for example, if you care about the proportion of people in the population who do all their Christmas shopping online. And then you collect the data and you find out that, okay, maybe here the sample we have a size 120, right? 750, I'm sorry. And you find out that 120 of them do uh, all their Christmas shopping online. So from that to estimate the true proportion, right? So you can also use a proportion population. So in this case, your n is 750, and your x here is the number of success here. In this case, 120, right? Because in your sample, you have 120 people prefer shopping, do all their Christmas shopping online. So at that point, you see like the p-hat will be equal to 120 divided by 750, and you do the math, you get a 0.16 here. So you can use that 0.16 to estimate the true proportion of people do all their Christmas shopping online. And this is a trend we need to look at, right? Because if the trend is that people just move all to shopping online, and then the in-store um, on-site shopping center, they have to find a way to adjust with that, right? And they need to make their program more attractive to people, find a way to make people go to the mall. I mean, in some way entertain, organize different event activities, right? So if they want uh, to pull back the customer in a traditional way. So here, the approach to here, the confidence interval, which you use interval to estimate the truth. So here, like the interval here, it's also constructed based on the sample data, and we also use the point estimate. But now you have something you call a margin error, E here, we know by E, okay. So your interval will be p hat subtract a to p hat plus e. So if here in the case, if we consider estimating the unknown proportion of the population, and we learn how to calculate the e in a couple of slides. And the same thing, if you want to estimate for the mean of the population, and then you use x bar, which is the sample mean, and also subtract and plus subtract e to x bar plus e. And again, we will learn how to calculate the e for the case estimate the mean as well. So in this figure, you can see that you have point estimate at the center here, right? The center here. And then you will also give them a little bit wiggle, right? Room, which is from the center you subtract error, and the center you plus error here. So here you have your interval will be, so instead of just a center here at a point estimate, you use this interval. And this side you call lower limit, and here we call upper limit. In full we say lower confidence limit, upper confidence limit. So let us revisit example 8.1.2 here about shopping online trained people. So here, like say we have another assumption here, which is suppose the margin error is 0.03. Okay, we learn how to calculate that, but here we just use it first, so we can get a sense what is confidence interval. So in this case, if your error is 0.03, and then your interval will be p hat subtract e to p hat plus e, right? And in short, we can write in this format, p hat plus minus e. So which in 0.16, you just calculated previously, subtract plus 0.3, and it gives you this interval. So this is your confidence interval, okay? So here a relationship between the confidence interval and the point estimate. So if you look at the estimation for the p, the true unknown proportion population, right? The unknown proportion population. So other time, if you use the confidence interval, it will be p hat subtract e and p hat plus c, and the p hat subtract e is the lower limit, okay? And I would say a lower CI, right? And the p hat plus e will be upper CI here. So if you do some math, okay, a little bit math here, you use this guy, the lower, you plus the upper, the E will cancel out and it leaves you with a 2p head, okay. Another time, you do the math, it will give you the p head will be equal to upper here, plus lower here, and divided by 2. You can replace it and you see it, right? It will cancel out with the E. And the same thing, if you use upper, you subtract lower, so the b head and b head cancel out, and E subtract up minus E, so it becomes 2E. So which means like, again, you can recover the error by using upper, subtract lower, and divide by 2, okay? So basically, like if you have your common interval, then you can find out what your point estimate p hat by using upper plus lower by 2. And you can also find out what the error is by using upper, subtract lower, divide by 2, okay? So it's just some basic math here. You can see that. And for sure, with the p hat, right? And you will need the E to recover the CI. And by doing p hat subtract E to p hat plus E. And the same thing for the mean. If you use the lower from the mean plus upper here, divided by 2, you also get X bar. And the error again, also upper of the CI, subtract lower CI and divide by 2. It's just similar, right? So in this example, we have like the confidence interval for mean length of a type goldfish is from 3.7 to 4.3 here. And find the point estimate X bar and margin error E. And so here, nothing, we just, apply the formula as above, right? So the X bar here will be upper plus lower divided by 2. In this case, if you use the 4, and the error will be upper subtract lower divided by 2, which is 0.3 here, okay? So let's look at this quiz. Express the confidence interval for population proportion in the form of pH plus or minus E. So in the part A, in part B, we have a confidence interval for mean, but expressed in the form of X bar plus minus E. So for this problem, basically like what our job is that we need to do that we need to find out what is pH, right? What is E for part A, and what's the X bar and what's E for part B, okay? So it should be easy, right, for this problem because it just directly apply what we just saw here. Find the p-hat by using that, the E by using that, and for part B, right, b-hat X bar by using this, and E by using this, right? So in this case, we can write it like this way, right? B-hat here equal to upper, right, plus lower, so upper in this case, 4 divided by 2, and E equal to upper. Remember, okay, upper, okay, subtract lower. The error must be non-negative, right? A lot of time I see you put it backward way and it give you a negative value, and when you do the multiple choice problem, you get trouble, right? Because a lot of time they are trapped on that too. Okay, so now just plug in your TI calculator, and you would be able to get your numbers, right? So just let's do one case here. So it will be 0.8. What is that here? 0.894, 872, 894, 872, 894, 872. Point 883 here, okay, so this guy 0.883, 894, 872, 883, 883. And this second part would be subtract, right? 894, 872 divided by 2. So 0.011, okay, 0.011. So the form will be point AA3, subtract minus, right? So this is your form, the desired form. And similarly, right, the X bar can also be written by this. Divided by upper plus lower divided by 2 and E. So you need to do this calculation, okay? Okay, and from that you can plug back to the formula format, right? Okay. So now we have a little bit of terminology we call the confidence level. And we as another analogy for solving for, right? Which is the CI is more likely to capture the true parameter than the point estimate. But one thing we should be able to recognize that, for a confidence interval, it has different levels. Okay, so there are, and each level it will tie with a term we call the confidence level. Okay, so we have different confidence intervals, and each confidence interval it will tie with a confidence level. Okay. And the confidence level is just the property of a confidence interval of 10, for example, that capture the true parameter. So say you just imagine, if you have a larger interval, right? You have a larger net, right? You're more likely to catch a fish, right? So basically like that. And for each confidence interval, it's corresponding to a confidence level, or we say 1 minus alpha times 100%, and for some small alpha, okay? And alpha here, we call it a significant level. So there are two new terminology, significant level and confidence level, okay? Confidence level. The significant level is a pre-specified value. It just depends on how accurate you want, okay? So often like, your alpha is smaller, so which means like your confidence level will be larger, right? Because the confidence level is corresponding to like 1 minus alpha, 1 times 100%. So for example, if you choose alpha a 0.05, and that time you plug in and you see that your confidence level will be in the 95%. And if you choose alpha is 0.01, and your confidence level at that time will be 99%. Okay. So in the case alpha 0.05, you have a 95% confidence level. And in the case alpha 0.01, you have a 99% confidence level. And with that pre-specified confidence level, your confidence interval will also change. Okay. And you should expect, when you have a higher confidence level, your confidence interval will be larger. And it makes sense, right? You're more likely to capture the truth. So in order to make that happen, right, your confidence interval has to be larger. You want more likely to catch a fish, right? You have to make the net bigger, right? A larger net, right? So here is the confidence interval interpretation. We should be very clear, okay, how to interpret the confidence interval. So say like if you have a 95% confidence interval, okay, and basically at the time you just like 95% confident that it contains the true parameter. A better way to think about that, like basically if we think in the reality, in the real world, so basically like if you repeat it, the same data collection process 100 times, each time you will want 95% confidence interval, okay? So at the time you should expect that about 95 intervals you build, it cover the truth, okay? So this figure below, it will be in represent like the blue intervals, okay? So here we have like 100 intervals here. You try to understand, estimate some and truth for the population, maybe the mean or the proportion, okay? And each time you build a confidence interval, so we have like 100 interval here in this figure, and then 95 of them, which is the blue one here, it's cross the black horizontal line here, right? So which means this is truth and untruth. So say proportion P, people favor new policy 0.7, the mean of height of US loyalty maybe 5.8 or something like that, right? And we also should expect that among 100 times like that, where about 5 times we will miss the true target. Okay, so in this case, for this figure, it's either the red interval. Okay, interval. So let us look at example 815 here. So in this example, we talk about the mean height of US adult, right? A 95% confidence interval. So based on the sample data about 1,000 randomly chosen adults, and we find that 95% confidence interval for population mean is from 5.1 to 6.1. Interpret the result. So just the same thing we just said before. So basically here, like in this case, if this is a case for the data we collected, right? We say that we're 95% confident that this interval contain the true mean height. Or we can say that if we collect the sample data one at a time and build the 95% confidence interval, about 95 of them, of those intervals will cover the truth, right? The mean height. And this is just a one sample, right? So for sure, we don't know for sure that this will contain or not, right? But we about 95% confident that it will contain, right? So you should be aware that this is just one sample data, right? So if we look at this track, right, and this is your interval, so you can think like this is just either one of the blue interval or maybe one of the red interval, right? But basically, if you do the bet on that, right, you should know that you're 95% confident, even your data collected in a right procedure, right? Right procedure. But for sure, you don't know whether you belong to the blue or the red. Okay, so this is the thing. Okay, you don't know with this time you belong to the blue or the red, but you're 95% confident, like you belong to the blue chunk, right? Because it's more common here, right? So we just discussed about the confidence interval interpretation. Now we will move on to construct the confidence interval. And first we look at the confidence interval for mean, then we move to the proportion. So previously, if you recall, we see that the confidence for mean, right? Interval for mean, we will do by x bar subtract plus e, right? The error. But how we calculate the error here, okay? The x bar is easy because it's just sample mean. So before we be able to do that, right? Just let us look at some notations. So n is sample size, x bar sample mean, L is sample standard deviation, sigma population standard deviation. And we have the mu, which is the population mean, which is the underlying truth, right? We care about. We use Z to denote a standard normal distribution, a normal 0, 1. And TK, which is a new distribution, okay? You will see from now on, which we call student T distribution with K degree freedom. So each student T distribution is had a, to tie with a degree freedom K here. So student T distribution it had a shape quite close to the standard normal distribution. Okay, it also symmetric around the 0, the mean 0 here. It also start low, high, middle, and end low. So pretty much like the bell shape, but the only difference is that it could give flatter. Okay. It kind of so you see that in the plot here, right? We have a standard normal, which is the pointiest guy here, in the light color curve, and then for the T distribution, it's kind of flatter to the bold light here, to bold curve here, right? So here, like the fastest guy is the T5. He much more flatter than the other two, right? And this is T5. And then T is 13, it's a bit pointier here, taller here. And then we can prove that mathematically. We can with math we can prove that like the T infinity. Okay, when the K degree freedom go big, and it will converge very nicely to the normal 0, 1. And often typical in practice, maybe more than 30, you should expect, it quite close. And then you also see two new kind of notation here, which is Z1 minus alpha by 2 here. So this is just a 1 minus alpha by 2 time 100% percentile value of Z. So say if I choose my alpha at 0.02, and other time my Z will be 1 minus subtract 1 subtract 0.02 by 2, so which is 0.99. So if at time my alpha 0.02 and I have Z 0.99, and this is just a 99 percentile value, of my Z distribution. And similarly, the T1 minus alpha by 2K here is 1 minus alpha by 2 times 100% percentile value of TK. So for example, again, if I look at maybe T alpha big equal 0.02, that time I will have a 99 percentile value of TK, okay, TK. And to calculate that, we just use the inward norm or inward T function from your TI calculator. So Z1 minus alpha by 2, you do inward norm 1 minus alpha by 2, 0, 1. And T1 minus alpha by 2, K, you do inward T function 1 minus alpha by 2, K here. So now we look at a little bit more about some characteristic of the T distribution, okay? So again here, distribution in TK equal the T distribution with K degree freedom. If it has the following characteristics. In continuous distribution, it range from negative infinite to positive infinite. It's symmetric, mean and mode equal 0. So pretty much like it has the same nature as the normal 0, 0, 1, right? To the same, exactly the same. It's T distribution type with K degree freedom, by TK, and TK will converge to Z for large K, okay? So just exactly what we just discussed before, but now we have a slide for that too. So let us look at how we construct the constraint interval for mean here. So if we have observation x1 to xn randomly drawn from population with mean mu, and we have some requirements to store in the next slide satisfy, and then we can construct confidence interval for mean by x bar subtract e, x bar plus e, and where e can be calculated, in different way for different scenarios. So the first scenario, if you submit a unknown, which is more typical, right? That's kind of standard in real data life, right? You don't know the population standard deviation. Another time, your error will be T1 alpha by 2, n minus 1. So other time, your T now has an n minus 1 degree freedom. Time S equals square root n. And for the case sigma non, okay, which is in some settings like computer generating number, say you want to borrow sigma from some more reliable data. Another time, E will be equal to Z1 alpha by 2 sigma by square root n. Okay, so you have to be when you do problem, right? You study, you have to be very careful about whether your sigma known or unknown. Okay, and most of the time your sigma will be unknown because it's the reality, right? But your sigma known, you say the given, right, in the problem, right? And you should go with the second track, calculate the E. So here the requirement 2 star. First, the sample is simple random sample. So this is a guarantee, we have a random sample procedure, and all, n sample size have the same chance of getting chosen, okay? The second condition is that sample size less than 5% of population size, which means we have a large enough population, right? Compared to the sample size. And then the population is normally distributed. So either you have this condition or the sample size large enough. So in this case, roughly speaking, okay, we use the n greater than 30. So basically, it just guarantees we have a reliable inference. So now let us look at this example. So we can see how we are going to apply the problem to find the confidence interval for mean. Using student aptitude tests that are score normally distributed. So we're given this condition. Okay. Aptitude score of 6 randomly selected students is are 88, 85, 86, 89, 73, and 82. Okay, so we have 6 students. Determine the 90% confidence interval for mean. Interpret the result. Determine 90% confidence interval for mean given sigma 5.4, right? So in the first case, we don't know sigma, which is often the real case, right? And by the second case, they give us a sigma. So maybe we have some big study previously, and we want to make use of that, right? So with that, right, how we construct confidence interval for mean here. So we did know that it's x bar subtract plus e, right? So the main point now is just the x bar is just a mean here, right? But what the e, right? What the e? So the e depends on the scenario, right? So scenario A, we don't know sigma, right? So let's look at this problem. So here requirement 2-star math. So basically like a good practice that check requirement, right? Sample, simple random sample because you randomly choose 6 students here, right? Sample size less than 5%. So size is correct, right? So samples are large enough. So in this case, we don't have large enough, but we do have the population normally distributed, right? So the third condition also met. So this is why we need normal here. And because it's met, right? So we can go ahead and apply the theorem. So this is a case because we want the 90% confidence interval, right? So which means at the time, which is basically we want 1 minus alpha 0.9 here. And from that, alpha is just 0.1. And basically like at that time, you can find out 1 minus alpha by 2 is 0.95. So this is needed, right? This will be needed to calculate the critical value. So the first case, when you have a sigma unknown, right? So basically at that time, you will go with track to find the error here. So you can plug it in your TI calculator, okay? With this sig value here, and from TI, you should be able to get your X bar and your S, right? Your S with the one variable start here. Put this one in L1 and you do one variable start, you should get the X bar in this value and your S here, okay? And we have 6 observation, 6. And given that your T, your error will equal to 0.95, T 1 minus alpha by 2, right? A minus 1, in this case, your A minus 1 be 6 minus 1 is 5, and time S by square root N. So which is you plug in, it will be invert T in your TI, 0.95 at 5 degree freedom, and time the S here, and divide by the N here. So if you do the math, you will get this error here. And from that, you plug in, right? It will give you interval. And you can interpret that maybe we are 90% confident that this interval includes the true mean aptitude score, right? In the second scenario, in this case, sigma is 5 to 4, so which means you have to follow this track to find the E, okay? Z1 alpha by 2, sigma by square root N. So at the time, E here is 1 minus alpha by 2 is 0.95 here. And the sigma by square root N, so sigma is the value given here, 5.4, right? 5.4 here. And divided by square root 6, and you get this much, and this is your interval, okay? And the same if you want to interpret this result, it's just the same, right? The same above, right? We're 90% confident that this interval includes the truth, right? The true mean aptitude score. So here's the good news. Actually, you don't need to do the manual calculation to obtain the interval. Now for the case sigma unknown, you can use option T interval in start test here to obtain the interval or the T interval. And there are two track, right? One track which is with the raw data you just saw in the previous example. You have raw data from 6 students. And that time you first need to insert the data in a list L1, L2. It depends on where you are, right? And then from that, after that, you say here we just fix with L1. Okay. And then like from that, you can choose the interval option, the interval option here, and insert the list here as this first box here, and it will give you the t interval you want. And in that case, say if you have process data, which means say if you survey like 1,000 students, right? Another time, maybe you survey 500 students, whatever. Another time, people sometimes they don't give you the raw data, but they rather than give you some summary statistics like the X bar, the S, right? The N, the sample size, right? The X bar with the mean, sample mean, the S, the sample standard deviation, right? And you can also obtain your interval. And similarly, you use a z interval function from your test start test here to obtain the interval for the case sigma non. Okay. So now let us just use the TI calculator and we'll go through the process together, right? So here we have the data 88, 85, 86, 89, 73, and 82. Okay. And there are two cases, right? But now we go with the TI calculator track. So I already inserted all the value here for you. So now we just do part A first, right? By finding confidence interval, T interval, right? Test here. You go to T interval and you want your data, right? L1 and you want confidence level 8.9, right? Because you're talking about 90% upon 9. So it gives you this value 79.025 to 88.642. Right? 642, which is exactly matching with a previous manual calculation. It's the same thing for the sigma non, right? You can do here the interval and sigma 5.4 here, right? And 80.207, 87.495, right? Which is also exactly match with the manual calculation here, right? So I would recommend, in your test, go with the second track. Okay, second track. So now let's look at another example. So here, checking account balance. So here, people they want to estimate the mean meal of checking account balance of customers. In a banker, they random sample 14 accounts and found that X bar equals to 664 and SE 130, and find a 98% correlation interval for mean, given data normally distributed. Okay. So for this problem again, we want to find correlation interval for mean. And before, basically, we need to process with the theorem, right? And before that, we need to check the condition 2 star, which means you can see that random sample, because they random sample to make sure, we have we know about intention purpose, right? Everything has to be random, right? So people get chosen in the same chance. A sample size less than 5% population size, which is also satisfied. If you don't have, you have either large enough sample size and greater than 30, or population normally distributed. So in this case, we have only 14 from sample size, but data normally distributed, so given here. In this case, you see that we don't have the raw data like we saw in the aptitude test problem, right? But we have the process data. So basically, we get the X bar and the S here. So from that, and also you see that the sigma unknown, right? So basically, you can use the T interval option here to get it. And you do the start and then test here. And do T interval here. Start 664,130, 14 and 0.98, right? So you get like the interval you want, 571.92 to 756.08. So which is exactly what I think, yeah, by 8, right? Exactly we get here, right? Now let's look at the quiz 821. Salaries of 35 college grads who took at least one start course have an X bar is $63,000. And sum transaction is $4,700. Verify requirements to store, construct 95% confidence interval for mean, and then 97% confidence interval for mean. So, but in this case, you assume that the sigma is none, the population standard deviation is none. Okay. So see, for this problem, we have all cases here, right? Which is two cases construct concurrent interval for mean in B, where the sigma unknown, and in C, you get the sigma known. Okay. So first of all, before we can process the concurrent interval, right, it will always a good practice if you verify the condition. So here the requirement to start requires three things, right? It requires either we have a simple random sample procedure, so which means it's just mean that or sample upside 35 student get the same uh, chance of getting chosen, right? So basically, like we want to make it a fair procedure in collecting data, and often in practice, this is just standard how people they collect data. And then sample size of less than 5% population size, so which means also it's satisfied because we have only 35 students and we have thousands of students who took start class, right? And third case, which is the sample size large enough, either n greater than 30, and if it not met, right, and we need the population normally distributed. So this case, because we survey 35 students, which is kind of large enough to make the inference reliable. So which means like all the conditions here satisfied. And then from that, you can safely go ahead and process the interval. So the first case, construct a 95% concurrent interval for mean. And again, we can always do manual calculation. At home, you can practice that, right? So it's help you build the understanding how the interval in the calculator is constructed, right? But I would advise you to use this, the TI calculator in your test room, okay? Because you have a time constraint. So for part B here, you need to do T interval, right? So let me just walk with you through that, right? So start here, you go test here, you go T interval. And in this case, you have the process data, right? 63,000 for the mean, 4,700 for the standard deviation, 35 for the sample size, and this 95, right? For the current level, right? 495. Okay. So here you have that. So you update it, right? So this is a $61,380, $85 to $64,615. Okay. So this is a T interval. So the 95% corner interval for mean, given this data collected, is this interval. Okay, this interval. And similarly, for C, now you want a 97 percent common interval for mean, and you have the sigma is known as 5,000. Okay, so at the time, basically just to start, right, and Z interval, right. So now you have to go with Z interval option. 6,000, 5,000 is a sigma, right? 63,000 for the X bar, and you want 97, right? 197. And this gives you the interval you want. $61,166 to $64,834. These are the two options we got. So be always be pay special attention on where sigma known or not.